Alrighty, so this is the second time recording this video. I accidentally had OBS like ultra zoom into my screen for the first recording. It looked like this for like the entire video, so that was kind of a bummer, wasting about 30 minutes. But also that's about 10 minutes too long than I wanted. So if you couldn't tell from the title of the video, this is a OpenGL game engine tutorial. I'm going to start going through some motions while I explain. So I want the goal of this is to be very modular. By the way, we're going to make a new empty project. So go ahead and just do that in the meantime. No precompiled headers. I want this to be a 3D game engine that has a very simple structure to it, but if you don't like it, you don't have to use it, because all of the OpenGL related stuff is going to be as modular as possible. It's not going to rely on the structure of the code or the way you format things. You can really send it however you want. You can really do it however you want it, but if you really don't care either, you can just follow my format of it to get a very nice running game engine in OpenGL, modern OpenGL, of course. So go ahead and we're just going to call this tutorial engine. Alright, so a couple things we need to do. We're going to go over a quick review. So these are some buzzwords you might have heard when I'm talking about OpenGL. GLEW, GLFW, GLEW, GLAD, GL.H, OpenGL32.lib, drivers and extensions. GLEW is a utility library, graphic GL utility library. You don't really see it that much nowadays. It was mainly for older OpenGL. We're not using that. We don't really need it, but it appears sometimes. For like you might see stuff like GLEW lookout or something like that. It's weird. Now this is something that you might see and you could honestly use if you wanted to, but we're not. It's called GLUT. It has a different license though, and it also hasn't been updated in forever. I don't know if it was even open source or not, but yeah, it was like GLEW. It was a graphics utility too, just like this, but it did windowing, so it would make context. So it would pretty much tell your drivers to render OpenGL to a window, because if you're not using that, if you're using a normal Win32 API, you're gonna have to do it. It's a little more complicated. So obviously they made free GLEW, which is more updated. It still hasn't been updated in a while, but I mean, it's not like it needs to anyways. It's pretty old technology. It's pretty simple to do. For windowing, we're going to use GLFW. So instead of using GLUT or free GLUT, we're going to use GLFW. It does input, has support for multiple monitors, multiple windows. It does context creation and windows. So it's going to make a window and it's going to tell our computer to render to that window. It'll handle that for us, so we don't have to deal with frame buffers and assigning certain contexts or whatever and whatnot. GLEW is, I'll get to GLEW in a second. GLEW and GLAD in a second. GL.H. I'll get to that side. So OpenGL32.lib and drivers. So OpenGL is stored inside the drivers. So if you could actually make a program right now just using GLEW is probably actually included with your computer. GLEW or GLUT, and even GLEW sometimes. But especially GL.H and OpenGL32.lib, these you do not download from anywhere. They come with your compiler. Yeah, that's just it. They come from your compiler. And the GL.H only includes OpenGL 1.1 and yeah, it's just 1.1. That's the old OpenGL. We're using modern OpenGL, which means we need access to 3.3. 3.3 is stored on our driver. Since it's stored on our driver, just like extensions are also stored on our drivers, depending on if you have NV underscore, AMD underscore Intel. I forgot what that stands for. I think it's pretty much like pretty accepted extensions, and then ARB is the like review board or something for extensions. We're not going to be using extensions, but yeah, these are NVIDIA, AMD. These are extensions for the drivers that the manufacturer gives out, that you can also utilize depending on if you have that graphics card. Now, if it's not available, then you just don't use it, and you can actually check if it's available inside your program. In the meantime, not only are these stored on the driver, but so is OpenGL 3.3, modern OpenGL. So it's an extension, which means just using GL.H is not enough. So we have to use an extension loader like GLAD or GLEW. We're going to be using GLEW because I don't know. I'm just more used to GLEW. It's a little bit easier in some aspects and a little weird in some others. So what it does, GLEW stands for GL Extension Wrangler. I'm not sure what GLAD stands for, but it does the same thing as GLEW, and it loads extensions. So it'll load these types of extensions in OpenGL 3.3. There's also core and compatibility, which means that if you use compatibility, you can use 1.1 functions along with 3.3 functions, but we're not going to be using old OpenGL, so we don't need that. But it is possible. It really just depends. So let's go ahead and get the two dependencies that we need, which is GLFW and GLEW. So from here, you're going to go ahead and go to GitHub repository, releases, and latest release 3.3, and you're going to go ahead and download the 32-bit version of that. It's also going to come with, and then same thing for GLEW. Links are in the description. GLEW and GLFW, we're going to download the binaries. We're not going to compile it because I want this to be as simple as possible. It's also just not that necessary, to be honest. So let's go ahead and show where to put these. So you've made a new solution and project, right? We're going to put our libraries inside of the solution, because as you can see, I share the libraries between different projects, like my tutorial engine, deprecated engine, and my latest engine. So we're gonna make a new folder called libs. Don't worry about include. Or actually, no, go ahead and make an include, and then there's not gonna be anything in that folder. These are what we're gonna end up putting in there from this 2 zip files we just downloaded. So if we go ahead and go into our downloads, which I've already downloaded them, so they're going to be inside of my library directory. I also already have everything set up. I'm going to show you where to put the things. So GLEW and GLFW. So let's start off with GLFW first. GLFW, you're going to want to go in, and these are for each Visual Studio version. So you guys are probably going to be using 2017 or 19. I don't know why it relies on your IDE version, or rather your compiler version for it, but it just does, and I don't like that. I'm not a fan of that. So the libs are where we're going to get the libraries. These are the precompiled. This is the precompiled code, and we're going to use a static version, which means we're not going to need a DLL at runtime, which means it's going to be packaged inside of our executable. So it's nice and neat. So we're going to go ahead and take the library. We're not going to use the DLL because the DLL goes with the DLL library. We're going to use the default one, which is linked statically. So you're going to drag and drop that into your libraries folder. And then you're going to drag and drop the include folder into there. Or you're just going to, or not drag and drop, you're going to just drag and drop that and put it inside of your include folder. And that way we have our headers and we have the library. I assume you guys probably already know how this works, but just in case you don't, I'm going to walk through it. Same thing for GLEW. We're going to go in. Binary has the DLLs and some testing executables. We're going to be using the compiled libraries, so 132 because we're doing that. So this is the normal one. So that DLL that we saw in that binary folder, we would have to package alongside our executable. But we're going to use the static library because it's honestly, it's just so much easier. I prefer static linking. We're not in the 90s. We don't need to preserve space as much as possible. It's only like a couple of megabytes bigger. So we're going to use the static version, GLEW32s.lib. And then don't worry about assemp. That's just there for my other projects. You don't need that right now. We might include that later. So there is our libraries. And then, of course, for the include, we're going to drag and drop GL into the include folder that we made. So we're just kind of merging everything into one big thing. So we don't have like a billion different include paths and library paths. So it's going to be very easy when we go over to Visual Studio. If you need help for another engine, say if you're on Linux or not engine, sorry, if you're on like Linux or you're using code blocks or dev C++, don't be afraid to ask for help. If you're using those and you're not too experienced. So right off the bat, I'm just gonna go ahead and delete these. These aren't folders, by the way, in Visual Studio. These are just filters, which explains the why inside of our thing we have VCProj and VCProj.filters, because these are all our little filters. So yeah, there you go. That's that. So we need to go ahead and tell Visual Studio where our files are now, just real quick, so it knows that we're reprogramming in C++. We're going to add a main file, and we're actually just going to test. We're going to write a little quick test program, main.cpp. We're going to go ahead and include IO stream. And man, don't worry if you don't exactly copy this down. You can. We're just going to do std cout tutorial /n. We're not going to use std endl because I'll explain why that's in a second. as we can see, it's probably going to work. So std endl, cannot include. Oh, yeah, you got to right click it and set it as your default startup project if you have some other things. Wait, why is that? Oh, I was using my YesHead engine, which is not what we wanted to use. So right off the bat, we're gonna go. It's gonna compile, yada yada yada, like normal. It's just a basic C++ application. So we use newline instead of endl because newline actually is just a normal newline character. When you use endl, it actually ends the input stream, which will slow down a little bit if you're rapidly sending stuff out. It isn't a big deal right now, but we're gonna be pros about it. So real quick for the preprocessor, since we are using the static version of GLEW, we need to add GLEW underscore static because it's not static by default, it's dynamic by default, and we're going to add this because it just requires it. So because if not, when we go to run it, it'll compile, but then when we go to run it, it will throw up an error saying GLEW init not found, which is going to be the one function from GLEW we're actually going to be using. Yeah, there's not a lot of them actually that we do use. So for C++, we need to set our include directories, which is pretty easy. If you decide to put your libraries inside of your project dir, you're going to use a macro, which is pretty much just like a quicker way to reference where your library's at. So we're gonna, for me, I have it in my solution dir. If you had in your project dir, you'd probably do something like project dir. I'm not sure what the exact macro is. If you want to look at all the available macros to you, which are just shortened versions of it, because if you look up solution dir, there we go. If you look up dir in general, there should be some other. That should be a project dir, target dir. That is the directory of where we want to put our target, whatever, yada yada yada. There should be project directory. So that's the directory of our project. So that would put in the tutorial engine project folder, but we have it in our solution, so we're not going to use that. So there you go. It's in our solution directory. Our includes are in \libs because we're on Windows. We use \libs/include, and that allows us to finally use our includes. And we're going to go ahead and do the same thing for the linkers. So we're going to do additional library dependencies, and same thing as last time. It's inside of our solution directory because that's where we put our lib folder. \libs, and then that's just it because they're just in that folder, and that's it. We go ahead and hit apply. Then we're going to go over to our input, and so there's three things we're going to link against. We're going to link against GLEW32s.lib for GLEW 32-bit static, semicolon, separate. We're going to link against glfw3.lib, that's just it, and then OpenGL32.lib for OpenGL, and then semicolon, separate the two. So that way we include our libraries at compile time. And go ahead and hit apply. So now we can go ahead and do some windowing. So this is going to be, since this is the beginner tutorial, or just the introduction or whatever, we're not going to write, like any advanced thing. We're just going to we're not going to do any error checking. We're going to do GLEW init. We're going to initialize GLEW. We're going to do glfw init. I'm going to make a almost forgot. Real quick, actually, we're going to remove this. You might encounter an error at one point that says something about gl.h being included before before GLEW. gl.h being included before GLEW, and it has to do with the way GLEW works. It just does not like being redefined. It breaks the entire thing. Because it's a header library, I'm assuming. There's no library. Oh, no, wait, there is a library portion of it. What am I talking about? I don't know. It's just the way GLEW works. I'm not a fan of it. So what we're going to do is we're just going to, anytime we want to access GLEW and glfw at the same time, we're just going to bundle them together. We're going to use this. It includes pragma once, and we're just going to go ahead and include them, gl/glue.h. And then the same thing for glfw/glfw3.h. There we go. So in our main file, there we go. It's included in there. And we're going to make a glfw window called win, because why not? So we made a window handle. Now we got to go ahead and call a couple things. Now we're probably just gonna have to do like when equals glfw create window. I'm gonna try to explain this as much as possible once I finish writing it out. So the first thing it takes is its width, the height, which we can store those in variables if you want, but this is a quick fix. This is the title, and then null, because the first one of them asks if it's full screen, and then another one asks if what monitor number if you're using full screen. It doesn't really matter because we're not going full screen now, and I forget if this one's monitor or if that one's monitor and this one's full screen or that one's full screen. I don't know. I'm just gonna give it a title. OpenGL tutorial. There we go. So we create a window after initializing GLFW. And we can go ahead and take a look on the website just to see. Yeah, you make a window, you initialize GLFW, which we swap that around. We make the window. We check to see if the window is valid, but we're not going to do it. GLFW make context current. So this little while loop right here, I could copy and paste, but we'll go ahead and do it ourselves. So we're going to do GLFW create context, or GLFW context, make context current window, or when. Do you give it the window handle? Yeah. So a lot of them are gonna. It's a pointer because a lot of these take a pointer to a window, which is how it manages multiple windows. Because you can have multiple windows spanning across multiple monitors, which is very nice. So we make context current. So we're gonna go. If we go ahead and run this though, it is going to immediately flash and close because it's not stuck in a loop. So what we're gonna do is we're gonna check should the window close, and by default it's going to return window should, there. And by default it's going to return false, but we're doing not that. We want to invert it because if it's false then we're going to exit the loop, but when it does it, it's going to be true, which is inverted, which makes it false, which makes the while loop exit. Normal C++. Don't forget to feed it a window, our window handle. So a couple things. First, let's make a clear color by calling GLClear. Clear color, sorry. We're just gonna make it a nice shade of red. So this takes an R, G, and B value and an A value, which is alpha, which means it's gonna be transparent. I've actually never experimented with modifying the alpha value because it's kind of weird when you think about it. I mean, where it's the clear color, how is it gonna be transparent if it's clearing the window? But who knows? So when we go to do that, we set their color, but we also need to call GLClear, of course. And so we're gonna have to clear our buffers, and I'll fill that in a second by glfw swap buffers. This pretty much what swap buffers does is it takes a window and it will pretty much refresh that window because we've rendered it. When we do our render code in between here, we want to refresh it, and then we also want to pull events, which all that does is just update all the windows on their current input. So that doesn't take a window because it affects all windows, I believe. So for GLClear, we're going to do GLColor buffer bit, and I'm going to start explaining what all this code does now. So far we've included gl.h, and we've made sure it doesn't get re-included for every program. And we've added out of stream. On our main method, we initialize GLEW and we initialize glfw. We don't error check these, but we will in the next episode because there's probably not gonna be an error, but you never know. I've actually never ran into it not working, but you never know. We make a window object or pointer, and we initialize it with width and height and a title and extra parameters. We make the context current, so we make our driver render to this window, which means it'll send it to that OpenGL context. We set the clear color, and then we make a loop that will not stop until we exit the program. We clear the color buffer bit, and now this is where all our rendering gets stored in. I believe it's our color. We want to clear that every time. This is where we're going to put our rendering code. We refresh our screen, and we pull events, and that's it. And then at the end, we want to do glfw terminate, and that will destroy all the windows. We don't actually have to do that. I actually forgot to do that in my tutorial for the last episode, but here we go. We got an OpenGL tutorial window, and that's it. You can modify the colors how you like it, but this is just the quick setup. I will record the other half of this tutorial probably tonight or tomorrow. Not other half, but this is it for setup. This is where we can start, putting our just normal, I can copy and paste all of these files in here, and it should work flawlessly. even with that lack of asset, because I actually haven't started using that yet. And so yeah, thanks for watching. I know this wasn't a very I know that it was a little bit more fast-paced than I want to be. I tried to be a little more slower with my explanations, but this is my second time recording it because I messed up the first time with it. But yeah, definitely next episode I'm going to start definitely walking through. So next episode we're going to make a mesh class. I know that's pretty exciting, and I'm going to explain what each one of the mesh functions do. In that tutorial, making that mesh class is when we make our first shader, and actually no, not shader. It's when we make our first triangle. We're gonna save shaders for the episode afterward, which you might actually have to follow both tutorials for you to get anything on the screen because, I'll explain tomorrow. But for now, goodbye.